Good morning. Today we will be working on plotting quadratic graphs. Okay, so don't forget that when we have a linear equation, and the linear means straight line. Okay, the equation of a straight line is always in the form y equals mx plus c. So an equation like that forms a straight line. Okay, a quadratic equation should have an x squared, okay, or if not an x squared, something like this, where you have x and then x, and they can be multiplied by each other and become x squared, okay, and that gives a curve. Okay, we have this kind of curve, and we also have this kind of curve. Okay, when we have this curve, okay, it's like a cave. Okay, it has the maximum point. Okay, it's a curve going up. That's the maximum point, and it's also called a maxima. Okay, you see the word maxima, it means the maximum point. This one over here, which is more like a U, okay, has got the minimum point, the least point over here. Once it reaches the minimum point, it starts going up again, and that can be also called the minimum. Now, for an equation to give this kind of curve, it should have a negative x squared. So if the equation has a negative sign in front of the x squared, it's going to become like an upside down curve, okay? But if the x squared is positive, like this one over here, okay, it's positive, then the curve is like a happy face, like a smile, okay? This is like a sad face, a negative, you can remember it like that, okay? Negative sign, negative face, sad face, positive, so smiley face. Now, to plot a quadratic curve, it's not like a straight line. Straight line, 3 points were enough. We need more than 3 points, okay? So it will be more accurate. Do not use a ruler to join from one point to the other, like we did in straight lines. This is different. We want it, all right, to become a curve. So we're going to join everything freehand and as smoothly as possible. So let's start with example 1. The graph of y equals x squared plus 2. So once we see this x squared, it means it is a quadratic graph, okay, and you're going to get a curve. What kind of curve, since it is x squared? Okay, that's a positive x squared, so it's a positive curve, okay, something like that, a happy face. Now let's start. X squared means x inside the bracket, okay, so it'll be accurate, squared, minus 1.5 inside the bracket, squared, okay? You can use your calculator if you want, or you can do it mentally, but don't forget, minus 2 times minus 2, and we have minus times minus, it's plus, okay? So on your calculator, do close it in a bracket, else you will get an incorrect answer, and that's a positive 4. Okay, minus 1.5 squared, let's say 2.25. Okay, don't forget, when it's a negative sign being squared, it becomes positive. Minus 1 squared, minus 1 times minus 1 is a positive 1. Minus 0.5 squared, minus 0.5 times minus 0.5, okay? So 0.25, okay, 0 squared, we get a 0, 0.5 squared, we get 0.25, 1 squared, we'll get a 1, 1.5 squared, we get 2.25. You see, they're like symmetrical. Okay, so 2 squared is a 4. Okay, now this is the same as in straight line graphs. That is the constant. It will remain exactly the same everywhere. So it's a plus 2 everywhere. Okay, now to obtain the y value, okay, we need the x squared and the plus 2. 4 plus 2, 6. 2.25 plus 2. Okay, etc. 1 plus 2. Okay, and so on and so forth. 5, that's 2, that's 2.25, that's 3. And even the values here are symmetrical. You see? 4.25 and 6. Why? Because the curve is going to be like this. And this is a symmetric curve. The points we have here are the same on the other side, okay? So have some kind of symmetry. Don't forget to obtain the coordinates, we need the x value, comma y. So minus 2, comma 6. Minus 1.5, comma 4.25. Minus 1, comma 3. Minus 0.5, comma 2.25. 0, 2, 0.5, 2.25, 1, 3, 1.5, 4.25, 2, 6. Okay? Now, we're going to start plotting those points. Use a pencil, as we said. So it's minus 2, 6. A little bit higher. Minus 2, 6. Minus 1.5. Okay, so you can see the entire graph. Minus 1.5, 4.25. And 4.25, this is in between 4 and 5. This is 4.5. 4.25 is over here, the 1/4. 4.1, 4.2, 4.3. Okay. Minus 1. Sorry, I got something wrong over here, so let me just rub it off. Okay, that was minus 1. That's incorrect. It's minus 1.5, 4.25. So minus 1.5, 4.25. Minus 1, 3. Next coordinate, minus 0.5. I'm getting them from here. They are x, y, okay? X, y. Minus 0.5, 2.25. Okay? 0, 2. And we're going back up. 0.5, 2.25, 1, 3, 1.5, 4.25, and 2.6. So you see? Okay, there's the curve as we thought it would be. So that's perfect. And that has a minimum point. So it's called a minimum. Okay? And this is the minimum point. Now, how are we going to join these? We're going to join them freehand. Okay? Oops, Shamantown. This is supposed to be here, 0.5. There. Okay. Turn your page so you're more comfortable to do that. You can use a flexicurve if you want. Okay. Okay, and there we have it. Do it as smooth as possible. All right, there's no need to rush. There's no need to press your pencil too much. Okay, it won't be perfect. Even mine over here, look, it can be a little bit more like this maybe. Okay. But sometimes it's even worse if you rub and then try to do it again. Okay, so question A. What is the coordinate of the minimum point of the graph? Now we know the minimum point is this one, also called the minimum. Alright, we aren't asked for the lowest value of y, but the coordinate, and the coordinate there is 0, 2. It's also called the y-intercept, where the curve is meeting the y-axis. 0, 2. Now, next question. Find the value of x when y is 3.5. This is the same thing as we did with straight line graphs last time. The only difference is that most of the time we're going to get two values. Okay, so find the value of x when y is 3.5. We go on the y-axis. We find that 3.5, which is exactly between 3 and 4. Okay, and we're going to meet the curve. We can meet the curve here, or we can go to the left-hand side and also intersect the curve over there. Okay, so let's start with this one. Okay, we meet the curve over here, and we read that value. Okay, mine there is around 1.22. Let's say 1.2, okay? Let's say 1.2, okay? Yours shouldn't be accurate to mine, okay? Anything in the same range between 1.2, 1.3, okay? 1.1, 1.4 is correct. And this one over here, okay? We intersected the curve, so I'm going to read that value. This is a symmetrical, right, along the y-axis. So this value is symmetrical to this one over here, and that's minus 1.2. Okay, minus 1.2. Next one, what is the y-intercept of the curve, of the graph? The y-intercept, where it meets the y-axis, and at this point, this is also the y-intercept because it is meeting the y-axis at that point, and the y-intercept means the y value there is 2. Does the graph crosses the x-axis? Does it cross the x-axis? Does it meet the x-axis? No, it never touches the x-axis, it never intersects, it never meets, alright? It never crosses. They're all the same thing, okay? So, no. So that was question 1. Let's try question 2 together. Plot the graph y equals minus 2x squared. So I've seen that x squared, so it means we're going to get a curve, a smiley or a sad face. The number in front of x squared is negative, so it means we're going to get a sad curve. Okay, that's that kind of curve. X values from minus 2 to 2. Okay, we're not using just minus 2, minus 1, 0, 1, 2. We're using more coordinates, so it will be more accurate. Okay, so this time, don't forget, we're substituting. We remove x and we insert minus 2. For this box, we remove x and we insert minus 1.5. For this box, we remove x and insert minus 1. Okay, so we copy it as it is. Instead of x, I'm going to write minus 2. We copy this as is. Instead of x, I write minus 1.5. We copy as it is. Instead of x, we'll write minus 1. Okay, copy as is, and instead of x, we write minus 0.5, etc., etc. Okay, and then you can use a calculator if you want to be safe, but don't forget, this is BIDMAS, and in BIDMAS, we first start with anything inside the bracket. There's nothing to work out inside the bracket, and then it's the indices, the powers, and I have minus 2 squared and negative, a number that is negative. When we square it, we get a positive value. That's what we said. So minus 2 squared is 4 wholes, and 4 times negative 2, 4 times 2 is 8 with a negative sign. That's minus 8. Let's see if I'm correct. Okay, so minus 2. We have a negative 2 inside the bracket. Please use those brackets, else you will get an incorrect answer. And there it is, minus 8. Okay, the same as this. So minus 1. So you can leave everything on the calculator as is, and instead of minus 2, we change it to the new value, which is 1.5. That's minus 4.5. Okay, this will be 1 whole times minus 2. And this will be, delete that one, arrange that, it's minus 0.5. Okay, 0 squared time will give us a 0. Now for these, okay, you can just, you don't need to write, you don't have to write these, okay, you can just use the calculator. Okay, and we have minus 2, and x is the one that changes every time. This is 0.5 now, positive. That's minus 1.5. Now x is 1, so I change what's inside the bracket to number 1. That's negative 2. 1.5, we're checking out next. And that's minus 4.5. This is 2. Minus 8. Okay. This is a plus 6, so it's a constant. Okay, it's going to pass through 6. It's a plus 6, okay, we add 6. But you can just write 6. And to get the y values, don't forget, we need this and this. Minus 8 plus 6, which is minus 2. Minus 4.5 plus 6. Please, if you are not sure, always use the calculator if you can use it. Okay? Make sure you write everything correct, and this way you will know you have the right answer and you will waste less time, okay? During the lesson you can use your brains, okay? But if you're during an exam, okay, it's easier to use a calculator to be safe. Minus 2 plus 6. Okay, 5.5. 6. 5.5. 4. 1.5. And minus 2. Okay, so we have x comma y. X comma y. X comma y. X comma y. Okay, etc, etc. And we have all the coordinates over there. So let's start plotting. Minus 2 comma minus 2. So minus 2 comma minus 2. Start from there. Minus 1.5 comma 1.5. So minus 1.5 comma 1.5 is positive, so we're going upwards. Minus 1 comma 4. Make sure you don't shift to another x's in the same way I did in the previous question, okay? Minus 0.5 comma 5.5. So minus 0.5 comma 5.5. 0 comma 6. And that's the turning point when it turns downwards, okay? And this is the line of symmetry. So 0.5 comma 5.5. 1 comma 4. 1.5 comma 1.5. And 2 comma minus 2. And we can start. So, boo. Okay, don't forget you have to obtain a curve over there. It's not a V. If it's a V, it's incorrect. If you're in doubt, send me an image and I will confirm it's fine, okay? And all the way down to the last point, okay? Doing it freehand is a little bit tricky, but there we go. Okay, so does the graph has a minimum or a maximum point? This is the highest point. That is the maximum point of the curve. Okay, it's a maximum. So I have a maximum there. What is its coordinate? What is the coordinate of the maximum point? So x is 0 there and y is 6. Now, find the value of x when y is 0. Y is 0 is the x-axis. Okay, because this is y is 1, y is 2, y is 3, y is 4. So y is 0 is this one on the x-axis, and x is 0 is the y-axis. And read the value of x there. Mine is around 1.567. 5 so minus 1.75. It's between minus 1.7 minus 1.8. Sorry, 1.75. Other side. Okay, it's minus 1.75. Now, if you have anything between 1.7, I guess, 1.85, 1.9, I think they're all correct, okay? Obviously, it makes a difference, right? Depending on the point of your pencil, okay, if it's sharp enough, and also until you get used to doing these freehand. Now, what is the y-intercept of the graph? And the graph intercepts the y-axis at this point. It means the y-axis over there, and the y value, sorry, there is 6. But that's question 2. I would like you to try question 3 and question 4. Okay, I have to arrange that on your own. Okay, try them out on your own, and we will be correcting them together. Let's check out your work. Question 3, you have to complete this table of values for y equals x squared. That is a curve. It's positive, so it's a minimum curve, a minimum, okay? Take 2 centimeter for 1 unit, 2 centimeter, this size, okay, for each unit, 1, 2, 3, etc. On both the x and the y-axis, plot the points and join them with a smooth curve. Let's start with the table. The table this time has 3, okay, rows. Why? Because we have x squared, we have minus 4x, and we have the plus 4, okay? But they're not difficult, okay? Because the minus 4x is the same as what we did in a straight line. The plus 4 is the same as what we did in a straight line. This is just different. And x squared, I already repeated that I already said that you have to insert that inside the bracket. Minus 1 squared, positive 1. 0 squared, which is 0. 1 squared, which is 1. Etc. 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 Minus 4x, which means minus 4 times x, this value of x, okay? So that's a positive 4. Minus 4 times 0, which is 0. Minus 4 times 1, which is minus 4, okay? Minus 4 times 2, which is minus 8. Minus 4 times 3, which is minus 12. Minus 4 times 4, minus 16, and minus 4 times 5, which is, minus 20. Okay, and the value is there of minus 4x, and the plus 4 is the constant where it will meet the y-axis, and that's always the same. Now don't forget, to get the y value we need to add now these 3 numbers, that of x squared, of minus 4x, and of plus 4. So I have 4 plus 4, 8 plus 1, 9. 0, 0, and 4. These cancel each other. Okay, 4 plus 4 is 8 minus 8 is 0. Okay, 9 and 4 will give us 13. 13 minus 12 is 1. And look at this, we're creating symmetry. 16 minus 16, 0 plus 4. So this will be 9. And there we have symmetry. Okay, when x is 2. There's the line of symmetry. So, let's start plotting it. Now, the smallest value of x is -1, the largest is 5. So, from -1, we need 2 centimeter, -1, 0, 1, 2, 3, 4, 5. So, I can shift it and start from here. So, it will be from here to here. Alright, now the y-axis, smallest value of the y-axis is 0. The largest is 9. X, we said from -1 up till 5. Okay, so 0 to 9, and we need 2 centimeter for each unit. So 0, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. We're making sure it fits, okay? So I'm going to shift it up from here. 0 will be here. I will have -1 and 0. So this is the origin. First, plan ahead, because it won't fit on your graph. So planning is important, and then you can start drawing the axis, okay, and marking them. So this is the x-axis from -1 up to 5. Don't forget we have 2 centimeter for each unit. Make sure you don't miss a number. And this is from 0 up to 9. Okay, so coordinates -1, 0, 4. Don't forget, we always take the x value and the y value, the x and the y. 1, 1, 2, 0, 3, 1, 4, 4, and 5, 9. Make sure your coordinates are correct, okay? So, -1, 9. -1 all the way up to number 9. 0, 4. That is the y-intercept, where the curve will meet the y-axis. And in fact, that was the y-intercept, the constant. 1, 1, 2, 0, 3, 1, 4, 4, 5, 9. Now, this tend to get a little bit more tricky to do it freehand because there's quite a distance. So I use this trick. Okay, what is it? I told you do not connect with a ruler, so this is incorrect. All right, that is incorrect, but I still use the ruler in a tricky way. So not as a straight line, I start a little bit like this. Okay, and move the ruler like this. You see the ruler moving? Look at this over here. Okay, you see the ruler is moving. So whilst I'm going down, I'm going to move the ruler slowly so it will form a little curve. Don't forget the curve here. The points are too far away, so it's going to be quite close to a straight line, but not a straight line. So look at this. Let's start a bit like that. And I'm moving the ruler. You see, now I made 4. And that's a bit curvy. Okay? That's how I do it actually. Okay, when they are far away, when the coordinates are far away, and then I can continue using the freehand method. Please, here, it's not a V, so it's a curve. You see this? It's not going to meet. So let me do it again. Okay. there. And the last one, I'm using the ruler. So, you see the direction of the curve going there, and I'm going to shift a little bit. Okay, whilst I'm drawing the line, the ruler is being shifted. And there we go. Okay, we have a very smooth curve. Yay. So, is this curve a maxima or a minima? We have the lowest point here, not a highest point as a turning point. Lowest point here, and that is a minimum point. So that is called a minima. So, what is the minimum value that y takes, and the lowest value of y, not x, of y, lowest value of y, there is 0. The lowest value of y. Write down the coordinate of the minimum point. This is the coordinate of the minimum point. That's 2, 0. Okay. Use your graph to find x when y is 0. When y is 0. And y, this is the y-axis, is 0 here. Okay. And what is the value there of x? When y is 0, x is 2. You can find it from the graph, and you can find it from this as well. This is x. This is y. When y was 0, what was the value of x? 2. We're talking about the same point over here. Okay? Use your graph to find x when y is 1. So now y-axis, y is 1. And okay, I'm meeting the curve over there, and I'm meeting the curve over here. So every time I intersect the curve, I read the x value. 1 is 1, x is 1, and the other value, x is 3. Sorry, there's a lot of noise outside. There's a construction area just opposite my window, and it's very close. And even though the windows are double glazed and closed at the moment, the sound is too much. So x is 1 and x is 3. Next question. Draw the line of symmetry and give its equation. Now the line of symmetry this time is not the y-axis. The line of symmetry is over here. So let's draw the the line of symmetry. We'll be doing this also in the topic of transformations, where we'll be doing reflection, and we would need a mirror line to reflect one side to the other side, or shift one shape to the other side of the mirror line. What is the equation of this line? Okay, this line is a particular line. Okay, it's not in the form y equals mx plus c, because it doesn't have a gradient. Okay, we only know that the coordinates over here. Let's take the coordinates. What is this coordinate here? It's 2, 9. What is the coordinate here? It's 2, 8. What is this coordinate? 2, 7. This 2, 6, 2, 5, 2, 4. The coordinates on the line: 2, 3, 2, 2, 2, 1, 2, 0. What can you notice about the coordinates of this line? There's a number which is always the same. Yes, exactly. X is always the same. And what is it? Well done. X is 2. Okay? And that is the equation of our line. X is 2. Because it's passing through the x-axis at number 2. And that is the equation of our mirror line, of our line of symmetry. Last one for this topic. Plot the graph of y equals 2x squared minus 2x minus 4 from minus 2 to 2. But we have a slight problem there. Why? Because we're not given the entire table. So you will have to build it up yourself from minus 2 to 2. But we have rows missing here. We have the 2x squared, the minus 2x, and the minus 4 missing. So let's create a table. Okay, so we have x values minus 2, minus 1, 0, 1, 2. That's x. Now this part on its own, 2x squared. This part on its own. And this part on its own. Why? Okay, so what do we have? It's 2x squared, mela 2, and instead of x, it's minus 2 squared, okay? Minus 2 squared, okay? That is a positive 4. But if you're in doubt, use the calculator. That's a positive 4 and then times 2, 8. So, calculator, 2x squared, 2. Instead of x, I will write a number there, squared. Instead of x, I can write minus 2. And there it is. It's 8. Okay. It's 8. Now for this one, instead of x, I write the minus 1. 2. Instead of x, I write the 0. It's a 0. Instead of x, I write 1. Okay, and the other one is 8. I have minus 2x, it means minus 2 times x, mela minus 2 times minus 2, in this case 4, minus 2 times minus 1, which is positive 2, minus 2 times 0, minus 2 times 1, which is minus 2, and minus 4. This is the constant, it remains always the same. Okay. And to get the y value, we need to work out all of these points together. The 2x squared, the 4 and minus 4. So 8 plus 4, 12, minus 4. That's 8. Okay, don't add this one. That's the x value. For the y value, I need 2x squared, this, and this, and this. All of them together. 2 plus 2, 4, minus 4, 0. 0, 0, minus 4. 2 minus 2, 0, minus 4. 8 minus 4, minus 4, 0. Now look at this. It's a little bit different than the others we have before, okay? I've got a missing part, not a missing part, I've got a line of symmetry, but it doesn't show clearly. This is symmetrical to this to this. We don't have this point. Okay, so it's going to be, it's a positive curve, so it's a smiley, but it's going to be a little bit like that. Okay, it's like we're having a missing part over there. Okay, let's start with the x's. We're not specified on how many x's we can use, so it's from minus 2 up till 2. Minus 2, minus 1, 0, 1, and 2. And the y from minus 4 up till 8. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and it's not going to fit. So instead of 2 centimeters for 1 unit, I will take 1 centimeter for 1 unit. So there's minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, minus 2, minus 1, 0 will be over here, and we need, okay, so this will be the y-axis. You can see better. Minus 4 I start here, I said, so if this is minus 4, minus 3, minus 2, minus 1, 0 will be there. This can be, sorry, this is the minus 2, this is the minus 1, so 0, always leave the same space apart. 2 centimeters for the x-axis and 1 centimeter only for the y-axis. Have 1, 2, and up till 2 is enough. From minus 4 up till 8. 1, 2, 3, 4, 5, 6, 7, and 8. That's the y-axis. Start plotting. Don't forget x comma y. So minus 2 comma 8, minus 1 comma 0, 0 comma minus 4, 1 comma minus 4, etc, etc, 2 comma 0. Okay, so minus 2 comma 8, minus 1 comma 0, 0 comma minus 4, 1 comma minus 4, and 2 comma 0. Okay, now this is different than the usual. Why? Because usually, okay, we get a point over there. So to check the exact coordinate of that point, you can try x is 0.5 and fill up the missing bar, the missing column, add an extra column in between, right, at a 0.5, so we will get the exact y value. Okay, but if you want, you can use a freehand, okay, to find that pivot point over there, but do not join with a straight line. That is not a straight line, that is a curve. So let's start this one. I'm going to cheat a bit because they're really far away. So not a straight line, please. That is not a straight line, it's a curve. So I tried something like this, and while it's going down, look at the way I am moving my ruler. Okay, now I continue freehand. And this, don't forget, we need to create a curve. And if you want to know exactly where this point is, let's add a 0.5 there. Let's add it. So let's find the value of this one. So that's 2. Instead of x, I'm going to write 0.5 squared. Then I have 0.5 minus 2 times x, minus 2 times x, which is 0.5. That's minus 1. Sorry. And we have a minus 4 there. So minus 4 minus 1. That's minus 5. And 0.5. So that's minus 4.5. So that value of 0.5 should be in minus 4.5. Don't forget, this is minus 5. So minus 4.5 is going to be over here. Okay? You could have done it freehand, but you could also, alright, add that extra point to find exactly where our pivot is going to be, and that is a minimum point. And we don't have to go up further because up until x is 2. And we have this curve, okay? As I said, it's going to have like a missing part over there. Okay? Make sure this is not a V, it's a bit bended. Let's start the questions. Does the graph has a minimum or maximum point? This is a minimum point. What is the coordinate there? X is 0.5 and y is minus 4.5. 0.5, comma minus 4.5. Find the value of x when y is 0. Y is 0. Y is 0 is this line over here. And the x value there is minus 1. And the x value here when I hit the curve is 2. So x is minus 1 and x is 2. Pay attention to questions like this because he can ask you for just the positive value of x. If you're asked for just the positive or just the negative, this is just the positive. Okay. Now find the values of 2x squared minus 2x minus 4. We need to find the value of. Now we know that this is equal to y. So basically here we're asked to find the value of y. We're asked to find the value of the curve. We know that is equal to y. So we're asked to find the value of y. Right? When x is 0.5, x is 0.5. This is the x-axis. When x is 0.5, the value of y there is, as we already said, minus 4.5. 4.5. Y is minus 4.5. What is the y-intercept of the graph? And don't forget, this shows us the y-intercept, the constant, and in fact it's right. Look, it meets the y-axis, okay, at y equals minus 4. The y-intercept, not the coordinate, and y there is minus 4. On the same set of x's, we are going to plot this graph. This doesn't have a squared, so that is not a quadratic graph. That is not a curve, that is a straight line. So revision of what we've done in the beginning of this week for a straight line. Let's do a quick table. We need the x values and we only require 3. 3 are enough for a straight line. So I'm going to start with the smallest value, the minus 2, the 0, and the 2. Minus 2, the smallest, the largest, and one in between. Okay, this part, to get the y. Okay. So 2 times x, 2 times minus 2, 2 times x, 2 times 0, 2 times x, okay, 4. Minus 3 is the constant, and it's going to be the y-intercept as well. Now for the y, we're going to add these two. X, comma y, minus 2, comma minus 7, 0, comma minus 3, 2, comma 1, etc., etc. Okay, mela minus 2, comma 7, 0, comma minus 3, and 2, comma 1. Great. So wait, I have a problem here. I plotted this one incorrect. It's minus 2, comma minus 7. I had to go down. Okay, so pay attention, because if I could do it wrong, then you could as well. Alright, we've been seeing a lot of numbers. So minus 2, comma minus 7. But I have a problem, because this goes just the way down to minus 5. So what am I going to do? I will have to change this one into another point. Let's take minus 1. Okay, so 2 times minus 1 is minus 2. Minus 2 and minus 3 is minus 5. So we're taking x as minus 1 and y will be minus 5. Okay, because we didn't have enough space down here to plot that point. Mela, when it's minus 1, it's minus 5. When x is 0, it is minus 3. And when x is 2, we have number 1. And now we can use a ruler, because this is a straight line. Okay, don't forget, this was the curve, and that was the equation of the curve. This is the line which has this equation. Okay, give the coordinates of the point of intersection of the two graphs. We need the point of intersection. Okay, point of intersection, I have 1 over here, and in reality, if I continue this point, they are going to intersect somewhere else. Okay, where do you think? So let's create the next point here. And if we create the next point, you see there's a line of symmetry here. There's a line of symmetry. So this is like this. This is like this. And when I shift one outwards, I'm going to get one over here. So I can plot that point to find approximately where the line and the curve will meet. And approximately my value is here. Okay, so they are meeting up. The point of intersection, I have 1 over here and over here. So x is minus 0.2 here. X is minus 0.2. On the y, there is 3 point, pay attention, it's not 3.2 now, because I only have 1 centimeter in between. That's 3.2, that's 3.4. Negative, because we're in the negative side, okay? Now the other coordinate, which is this one, the x value there is around, mine is around 2.25, but anything which is close is correct. Mine is around 2.25, and y is 1.2, 1.4, 1.6. Okay? And that's the end of this chapter. I know this has been a long one, the quadratic curves, okay? But I hope you understood. If you do have a problem, do not hesitate to ask, okay? Don't forget to always fill up the table, okay? By substituting, okay? And then plot the coordinates you will get, and use a pencil and draw freehand smooth curve, okay? So thanks for now, and I might see you after the Easter holidays now. So happy holidays.